Okay, last time we looked at this reaction, and uh, we got these results. So I started off. We have iron, and iron's in a nail form, and we weighed it, and it was 5.47 grams. Okay, and and then when the iron gets reacted, it is now less. So the iron nail now weighs 3.02 grams. So the iron disappeared and went somewhere. I mean, presumably, you're thinking, well, where'd it go? It's out there, right? But it's in a beaker. Same with the copper. Where did the copper come from? Well, we see that copper. We start off with no copper, but I mean the copper is there in a different form. But now we have solid copper, and so we have these two masses. It's 87.38 grams to start the empty beaker, and then we have a dried amount of solid copper in this beaker. We weighed that out, and we can see that we have different amounts of copper and iron. So the first question that we're thinking about is, well, how can we still say that the law of conservation of mass is still upheld, even though these masses are a little different? They're quite a bit different, but how can we say that conservation of mass is still going on? Because we didn't break any laws here. We still have conservation of mass holding still. So how can we say that? Okay, now it's coming to, well, why are we using this thing called the mole? Because I have grams of things. I love grams. Grams are easy to weigh, but I have two different amounts. And so remember, in chemistry or in different sciences, it's oftentimes easier to compare things if we are counting them. And the mole is a counting number. It's kind of like if I have dozens of something, I can compare dozens of eggs and dozens of donuts, and they have the same amount of numbers. Same with moles. I need to get moles of things. And so what I'm going to do with these numbers is you're going to take them and change them to moles. And the way we do that is we use a dimensional analysis or factor label method. And you might need to get your periodic table out for this. So you're going to take the grams of Fe, and you have a ratio here now. So we have the ratio, and make sure you have your all the things labeled. So you look at your periodic table, and using molar mass, how many moles is this? Okay, so we have the moles, and then what we're doing here is, let me see here. Okay. This here, make sure that you have units on your numbers. So on your numbers, everything has to have a unit, like grams or moles. And you're showing your work. And so when you have dimensional analysis, you got to have these things so you can see what's canceling out, because whatever's up here has to be canceled out down here. Same with a label. So I'm going to get on you. You got to use labels here, because if you have grams of iron or grams of copper or grams of manganese or sodium, they're all different things. And so you got to have a label also on your number. So the number, a label, and a unit and a label. And that's got to happen on all these things here. So, you look at your ratios, do the same thing for copper and see how much copper did you get? How many moles of copper did you get? And then when you get these two answers, we're going to take a look and see how do they compare? So is it in, what kind of ratio is it? So is it roughly the same? If it's roughly the same, it's a 1-to-1 ratio. If it is, if it's double one, if one's double the other, it's a 2-to-1 ratio. If it's triple, then it's a 3-to-1 ratio. And then we're going to take a look at this slide and see how do these numbers compare with one another when they are when you look at the model. Okay, so the model shows that, remember, all these coppers that were out here, they get stuck on here. So I have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 coppers, 6 coppers that have been stuck on here. How many irons left the nail in comparison? Now, don't worry about these ions on here. These are the ions that are not reacted, but the reacted ions. So this here, and so on. All these ions out here, how does the number of copper and the number of ions compare to each other? And what does that tell me about the ratio of the moles that are being reacted? Okay, so think about those things, and we'll come back the next lesson and try to figure all this out.